Good afternoon, class. In today's video, what I'd like to do is to go over rotational motion, but this time, instead of just going over the equations like I did in my introduction to rotational motion, what I thought I'd do is I'd try my artistic skills a little bit and try to draw this out a little bit. So I'm going to take linear distance and find its analog in angular distance. And so what I thought I'd do is I'd show you some of the similarities and differences between linear motion and rotational motion. So with linear motion, it's fairly easy. X equals vt. We have seen that before. We have studied that in linear motion already. It's fairly easy to understand, or at least it should be more familiar at this point. Very intuitive, you might say. Now we'll go on to rotational motion. Now this is a little bit different because this person is walking along a road, let's say. They're walking on the ground, they're going a certain distance. However, if this person starts walking in far enough, because we're on Earth, they'll start to curve around the Earth like this. They'll actually have an arc length that goes around the Earth. So what does that look like? Well, that distance can't be measured in a straight line like we did before, so we actually have to have a whole new term. And if you want this, the analog to distance here, like linear distance, it would be arc length, and that's going to be r theta. So r is the radius or the distance from the center of this circle all the way to the edge. So this is r, this is also r, and the angle between that is theta. So I thought I'd point that out. This is the arc length, and that is what we're going to be using if we really want to move between linear distance and angular distance and talk about the actual physical distance that you actually moved. You would use arc length and distance. Now, what about if you wanted to find the analog in terms of this equation? Then that would be the equation for theta, which is theta is equal to omega t. Okay, and again, as I pointed out in the last video, omega is, this is the Greek letter lowercase omega. It stands for angular velocity. This is not the same thing as the capital omega, which is what we use for the symbol for ohms or resistance in electricity, which we'll get to later on in the course. So this is hopefully an example where you can kind of see the difference between angular or rotational motion or distance and linear distance. So good luck in your studies. I'll see you in the next video.